Greetings, this is Dr. McGuire, and this is the second screencast for Chapter 17, in which I primarily will cover information stemming from Section 17.2, the chi-square distribution and degrees of freedom. So one of the obvious goals is how do we calculate degrees of freedom for the chi-square, and then locate the critical value for a specific alpha level associated with our chi-square. Second, how do you conduct a chi-square test for goodness of fit? Now we started this in the previous screencast but didn't quite complete it. And then finally, I want to show you how you can conduct the chi-square test for goodness of fit in SPSS, and there's two different approaches one can use. For starters, to decide whether a particular chi-square value is large or small, we have to look at the chi-square distribution to determine that. And what we'll find is, like other distributions, we'll see a set of chi-square values for all the possible random samples when the null hypothesis is true. The chi-square distribution is a theoretical distribution with well-defined characteristics, so it's positively skewed given that we are looking at units that have been squared. So you can never have a negative chi-square as a result. The other thing is that the distribution is going to change shape as we increase our degrees of freedom. When the null hypothesis is true, you expect the data to be close to the hypothesis, the null hypothesis, or in other words, the expected frequency values. And when you have little difference, then chances are you're going to get a very small chi-square. The more your observed values vary from your expected values, the more likely you'll have a significant chi-square. For the goodness of fit test, the degrees of freedom are determined by the following: C minus 1, and C is the number of categories. Another way to think of this, and probably the more appropriate way to think about this, is how many levels are associated with your independent variable. Here is an example of a chi-square distribution. Like the F distribution, you're going to see a positively skewed distribution of values. And whenever we set alpha to say 0.05, any chi-square value that falls into this critical region will be considered statistically significant. And here's how the shape of the chi-square varies as a function of degrees of freedom. The other thing to point out about the degrees of freedom is this has nothing to do with the number of participants in your study or whoever's study. It's all about the number of levels associated with your independent variable. So for example, if we look at this distribution, degrees of freedom equals 9, that basically means they're looking at 10 categories of people, or 10 categories of some type of variable. All right, how do you find the critical region for a chi-square test? Well, you normally look at a chi-square distribution table. I say normally, but when I start thinking about it, I hesitated because normally you're conducting this on SPSS, chances are. So if you are doing this by hand, you would be using or consulting the chi-square distribution table. And it's going to be set up very similar to previous tables. You're going to see a column associated with degree of freedom values, and then you're going to see a top row that's associated with alpha levels. And again, these correspond to the kind of cutoff marks in the distribution, and they cut off the extreme right-hand tail of the distribution. And then the numbers in the body of the table are the actual critical values of the chi-square. So for example, here is a copy of a portion of the chi-square distribution table from your appendix. And in the example we were looking at in the previous screencast, we actually only had two categories of participants. One was those that were greater than 25 years of age and those that were less than 25 years of age. Well, given that we're working with two categories, 2 minus 1 equals 1, so our degree of freedom for our previous chi-square analysis would be 1. And if we look at the problem at the end of the chapter, it's asking us to set alpha to 0.05 in which case we look at the appropriate column, which is here, and now we know what our cutoff value is, and that is 3.84. So now we need to compare our obtained chi-square value with this value. And so let's do that. Let's turn our attention to Excel. All right, and so here is our obtained chi-square value, and that is in fact greater than our critical value of 3.84. So we would, in this case, we would reject the null hypothesis. And then if we look, our null hypothesis is as follows. Data from the motor vehicle department indicate that 80% of all licensed drivers are older than age 25. Well, basically what our findings, since we're rejecting the null hypothesis, we did not find that 80% of all licensed drivers are older than age 25. All right, so we have calculated a chi-square manually in Excel, and then we found what the critical chi-square value was and compared our obtained value. That about does it for the Excel portion of this. Let's now turn our attention to SPSS. All right, so for starters, we want to enter in our variable that we are measuring here, and that is frequencies for whether you're for two groups, greater than 25 years of age and then less than 25 years of age. So I'm just going to put age category here, or I shouldn't probably say category, age group. And then I am going to insert values. So a value of 1 means that this is associated with greater than 25 years of age. And then a value of 2 is going to be associated with less than 25 years of age. And so I add those and click OK. Now the other thing to point out is that this is just yes or no. This really is a nominal category. You're either in this group or you're in another group. So we will select nominal from here. And now I need to enter my data. So I need to go to the data view because right now I'm in the variable view. So when we look at our original data set, we had 33 people that were in the greater than 25 years category. So I'm just going to put 1. Okay, so that means you're in the greater than 25 years of age category, and then I'm going to copy that, Control Copy, Control C, and then I want to select all these cells where I want to paste that value. Okay, and then Control V. There we go. All right, for the remaining 17 participants, they fell into the less than 25 years of age category. So I'm going to enter a number 2, hit enter, and now I see less than 25 years. So I'm going to copy this and then paste it in these cells going up to 50, because altogether I have 50 participants. All right, now once I do that, the next step is to run the analysis. So I come over here to this menu, to the Analyze menu, and then I want to go down to non-parametric tests, and then I need to go to Legacy Dialogues and select chi-square. Whenever you first do this, the age group will be in this box, and you need to move it over to the test variable list. And then you have to let SPSS know that in this case, all categories are not equal. We're not expecting the same frequency within the greater than 25 years of age and the less than 25 years of age. In fact, we're looking at 80% in the 25 years of age, and then, 80% in the 25 years of age, and then 20% in the less than 25 years of age. So if I'm expecting 80% of my frequency observations to be in the greater than 25 years, I need to calculate what is 80% of 50, and that turns out to be 40. And so I just click 40 there. And so that means that 20% of 50 is going to be 10. And the other neat thing that you can do, let's say if you get something that's hard to multiply, is you can just pull up your calculator and maybe have a shortcut. Anyway, so you can say, okay, what's 0.8 times 50? Right, so you can do this, have this off to the side, or I mean you could have this, you could have Excel up and running and run these calculations too, but maybe using the calculator is easier. Anyway, so now I have what the expected frequencies are for this data set, and now I simply just click OK, and there are my boxes. I get one box that shows me what my observed frequencies were, and I can just double check, make sure that's accurate, which it is, and then what we were to expect if the null hypothesis was true. And then I can look and see that in fact my chi-square is the same as what I calculated over in Excel, 6.125, and now I get the specific probability of getting this chi-square. That is 0.013, so that is the probability of committing a type 1 error. So about 1.3% chance that this is a type 1 error. Anyway, so that's one way to calculate it in Excel. Here is another way, and I'm just going to go ahead and use the same. Actually, let's get rid of this. Let's get rid of this column by clearing it. Okay, so I'm going to come up with the, let's see here, I'll call it the IV. This is the independent variable, and this independent variable has two values. It has a value of 1 that is equal to greater than 25, and a value of 2 which is less than 25. And then I also need to let the program know that I'm dealing with a nominal variable. Now I'll go back to the data view, and so we actually have two categories. One is greater than 25 and the other is less than 25. Now let's create another column and we'll just call it frequency. Okay, and this again is nominal. And now I put the frequency of greater than 25, which we found to be 33, and then I input the frequency for less than 25, which turned out to be 17. Now whenever I am entering the data in like this, so instead of going one at a time, I'm grouping them according to frequency, I need to weight these values. I need to let SPSS know that this category is receiving 33 observations and this one's receiving 17 observations. And to do that, I have to go to the data menu, and then I have to scroll down to where, whoops, where'd it go? I need to scroll down to where I need to scroll down to weight cases, and it's way down here near the bottom, second to the last option actually. And so which is, what am I going to weight my cases by? I'm going to weight my cases by frequency. This lets SPSS know that this variable is being weighted by frequency. Alright, and then I click OK. And now I can run this test again. But before I do, let's get rid of this old output. I'm going to just delete all that. And by the way, you can run analyses when you're in your output window, which is what I'll do. Analyze, and then non-parametric tests, legacy dialogues, chi-square, and then our test variable. Well, let's reset all this. Okay, our test variable is the IV. And in this case again, what are we expecting? Well, for the very first value, for the very first category, we are expecting 40 observations. For the second category, we are expecting 10 observations. All right, and then I just click OK. And voila, there are my two categories, greater than 25, less than 25. I probably shouldn't have used the term IV for independent variable. I probably should use something like age category or something, but you still see what happened here. We get the same thing that we got before. And furthermore, we have our chi-square value, which is identical. So this approach is probably, of the two, probably more efficient than entering in data one by one. All right, so this is all I have for this screencast. What we did, again, as a recap, we looked at how to compute the degrees of freedom for chi-square. We computed chi-square. Actually, we finished the computation of chi-square in Excel, and then we figured out whether it was significant or not. We also learned how to compute chi-square in SPSS, doing it one of two different ways. So until next time, have a good one.